Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 4.4a of our virtual geometry text on triangle properties. We're going to be looking at how to find the centroid of triangles. So the problems we're going to be working on are captured in this example that we have here. So you have to find the coordinates of the centroid of the triangle, given the triangle where the vertices are on lattice points. Don't forget, we have 4 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. To gain access to our entire geometry, algebra 1, 2, pre-calc, and calculus courses, just take a look at the links in the description below or visit our site at mathgotserved.com. To get us started, we're going to take a look at the formula that's going to be guiding our problem solving process. So this is our page, mathgotserved.com/geometry. We're going to scroll down to the must know geometry formulas. Okay, so formula number 14 of our must know geometry formulas is the formula that we are working with today, which is the centroid formula. And if you notice what it states here, the centroid of a triangle with vertices x1, y1, x2, y2, x3, y3 is given by the sum of the x coordinates divided by 3 for the x coordinate of the centroid and the sum of the y coordinates divided by 3 for the y coordinate of the centroid of the triangle with these vertices. Alrighty, so this is the formula that we're going to be using. If you want to gain access to this and other valuable resources, you can just visit our website at mathgotserved.com/geometry. All right, let's take a look at question number 1. Instructions for the examples we're going to be working on for today, the first two. 1 and 2 is as follows. We're to find the coordinates of the centroid of the given triangles and then sketch it on the triangle. Okay, so let's look at number 1. We have triangle ABC. We're to find the centroid of this triangle. So what we're going to do first is we're going to determine what the coordinates of the vertices are. So for point A, this is -5, -5. For point B, the coordinates of this vertex, this is 1 right here. Coordinates of this vertex is -5, 1. Oh, small mistake. For point A is actually -6 for the x coordinate. So -6, -5. All right, and then for point C, the coordinates are -1, -5. All right, now what we're going to do next, now that we have the coordinates, we're going to write down the formula that will guide our problem solving process. It's the formula that we looked at earlier from our website. So the centroid is basically the sum of the x coordinates, x1, x2, x3, divided by 3 for the x coordinate of the centroid, and then y1 plus y2 plus y3 divided by 3 for the y coordinate of the centroid. Alrighty, so we need 6 values in order to determine what the centroid is: x1 to 3 and y1 to 3. Okay, so let's go ahead and label our points so we know exactly what goes where. So point A is -6, -5. Point B is -5, 1. And then point C is -1, -5. Okay, let me just check it again just to make sure. -1, -5, okay. And then -6, -5, okay. And then -5, 1. All right, so these points right here will tell us what our values are. So this is x1, y1 for the first point. Second point, x2, y2. And then third point, x3, y3. It doesn't really matter the order that you place them in. You will still get the same answer. Okay, so the centroid is going to be sum of the x's, -6 plus -5 plus -1. That's x1 plus x2 plus x3. I just substituted it here. All the sum of the x coordinates divided by 3 will give us the x coordinate of our centroid. And then for the y coordinate of our centroid, y1 plus y2. I don't need a parenthesis for that since it's positive. So y1 plus y2 is 1, plus y2 plus y3 negative 5. Okay, so that will give us the y coordinates of our centroid. So now what we're going to do is use the order of operations to determine what our coordinate values are. So for the x coordinates, we have, oh, they're all positives, right? So we have, it just reduces to negative 6 minus 5 minus 1 over 3, because when you multiply positive and negative, you always end up with negative, right? And then over here is going to be negative 5 plus 1. And then positive times negative, anytime you multiply different signs, it's always a negative. Over 3. Now, using arithmetic, order of operations, the numerators group together, so we'll do that. Negative 6, negative 5, negative 1. All the signs are the same, so you add and keep the sign. Okay, so this would be negative 12 over 3. And then over here, negative 10 plus 1 is negative 9. Negative 9 over 3. Now we're going to go ahead and divide. When we divide, we get our centroid, which is negative 4, comma, negative 3. All right, so that's our centroid. Let's go ahead and graph it on our triangle right here. So the centroid is negative 4 right here, and negative 3. Bam. So that's the centroid. Okay, so what's the significance of this? Now imagine that this were a table. Okay, this is the top of a table. We have a triangular top of a table, and you're asked to balance it with only one leg. Where are you going to position the leg so that this triangular table balances? Well, the centroid is basically the point where the center of mass of this entire triangular object lies. So if you place one leg underneath this point on this triangular table, guess what? It is going to balance this triangular top perfectly. Okay? So that's one of the significances or the consequence of the centroid in physics. Okay, let's take a look at question number 2. So for problem number 2, let's say we have coordinates GHI. Those are the vertices. Okay, so we want to do the same thing. We have to find the centroid of this triangle and then graph it. Let's go ahead and determine what the coordinates of the vertices are first, and then we go from there. For point G, the coordinates are negative 7, okay, xy. And then for point H is negative 2 on the x and negative 1 on the y. And then for point I, the coordinates are 0 on the x and negative 7 on the y. All right, so we have the formula right here. We don't have to write it again. Let's just write down what our points are. G is negative 7, negative 7. H is negative 2, negative 1. I is 0, negative 7. So this is going to be our x1, y1, x2, y2, and then x3, y3. Okay, so we're going to plug in these values into our centroid formula here. So our centroid is simply going to be the sum of the x's, so negative 7 plus, that's x1, negative 7 plus negative 2 plus 0, that's the x coordinate of our centroid, that will be divided by 3. And then for the y coordinate of our centroid, we're going to be looking at y1 negative 7 plus y2 negative 1 plus y3 negative 7. All that divided by 3. And that will be the y coordinate of our centroid. Let's go ahead and simplify that using the order of operations. Here we are going to have negative 7, so we have negative 7 plus times minus is minus 2 over 3 for the x coordinate. And then for the y coordinate, it will be negative 7 minus 1 minus 7. Remember, when you multiply different signs, you always get negative. Alrighty, so that will be divided by 3. So let's simplify using order of operations. The numerator operations are grouped together in the parentheses. So you have an invisible parenthesis here and here. So we'll do that before we divide, following the order of operations. Please excuse my dear Aunt Sally. Okay, so our group numerator operation, combine that, you get -9 over 2. Nope, over 3. And then for the y coordinate, -7 minus 7 is -14 minus 1. -15, all signs are the same, just add and keep the sign. Bam, like that. So let's divide for the last operation. That will give us what our centroid is for triangle GHI. In number 2, the centroid is now going to be -9 over 3, which is -3, and -15 over 3 is -5. Bam. That's the answer to question number 2. Let's go ahead and graph that. -3, -5. The centroid is going to be located here, -3, and then 2, 3, 4, 5. You know, this has kind of sort of in the center, right? So that's where the centroid should be, -3, -5. The centroid should always be somewhere in the center of the triangle. It shouldn't be somewhere outside. All right. Ladies and gentlemen, that's the answer to number 2. We're going to do one more problem, and then we will give you an opportunity to do some practice to demonstrate mastery. All right, let's take a look at question 3. In question 3, we are given just the coordinates, a numerical representation of the vertices of a triangle. So in this particular case, we have to find the coordinates of the centroid with the given vertices. So let's go ahead and work this out. So we know what the formula is for finding the centroid of a triangle. Let's review that real quick. So the formula is as follows. The centroid of a triangle is the sum of the x coordinates of the vertices x1, x2, x3 over 3 for the x coordinate, and then y1 plus y2 plus y3 over 3 for the y coordinate. Now, so we're given 3 points. So K is x1, y1, I is x2, y2, and then M is x3, y3. So we just substitute these values into our formula to determine what the centroid of triangle KIM is. So the centroid is x1 plus x2 plus x1 plus x2 plus x3. Divide that by 3. And then for the y's, y1 plus y2 plus y3, that divided by 3. Okay. All right, so let's go ahead and simplify this using the order of operations. Please excuse my dear Aunt Sally. So just imagine, as we did before, in the numerator, assume that these operations are grouped together. There's kind of like an invisible parenthesis there. So we'll take care of simplifying the numerator first before we divide, okay? All right, let's do it. So on the numerator, -1 plus 7 is 6 over 3. And then 6 plus 6 here is 12 over 3. And then the final answer for the centroid of triangle KIM is 2, so 12 over 3 is 4. 2, 4 is the answer to problem number 3. Okay, it's now your turn to do some practice problems. We have 4 problems for you to try out. Instructions for 1 and 2 is to find the coordinates of the centroid and graph it. And then for 3 and 4, just find the centroid of the triangles with the given vertices. Alrighty. So go ahead and pause this video presentation at this time. Work on these problems. When you're done, click on the playback button, and we are going to reveal what the correct answers are. Welcome back. Hopefully you had a chance to try the problems. Let's take a look at what the answers are. For problem number 1, the centroid is 1, 2. Graph that, 1, 2. There's a centroid right there. For number 2, the centroid is, what is it? It's 5, -2. It's right here. Bam. And then for number 3, the centroid is -2, -1. And then for number 4, the centroid is 19/3, comma, -8/3. All right, ladies and gentlemen, how well did you do in these practice problems? Let us know in the comments section below how well you did. If you have any questions or clarifications you want us to make for you, specify it in the comment section and we'll be more than glad to assist. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful or you would like to share this content with others, just give us a like or a thumbs up. Your positive feedback is extremely valuable to us. Do not forget to subscribe to our channel for updates to other presentations such as this. For tons of support resources to help you master geometry, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.